Hi guys, welcome to this video on grade 11 trigonometric expressions. In this video we're going to be having a look at how to factorize trigonometric expressions. So we will be looking at the different methods of factorizing, the common factor, difference of two squares, trinomial, sum and difference of two cubes, as well as grouping. Now there are times where you need to be able to solve trigonometric equations. You'll be requested to find the general solution, or you just have to solve or prove trigonometric identities. In such instances, it is vital for you to have an understanding on how to factorize trigonometric expressions, as many a times the questions that you'll be presented with will require that you be able to factorize the trigonometric expressions. And as we've already mentioned, the different methods of factorizing, we've got our common factor, difference of two squares, the trinomials, the sum of two cubes, the difference of two cubes, as well as grouping. And in this video, we're going to have a look at each of these techniques as well as examples on how to go about solving them. So without any further ado, let's start with the common factor. So what do we know about a common factor? We have two or more terms which have a single trig ratio that's present in each of them. Now, if you look at algebra, for example, you identify the common factor by a variable which is present in every term in your expression, or a number which is a factor of every coefficient in your in your expression. So, in order to simplify an expression with a common factor, the first thing you need to do is you need to identify what the common factor is, and then you need to write it outside of a set of brackets. Secondly, you need to then take each term, divide it by the common factor, and write that answer inside of the brackets. In other words, we are writing each term without the common factor. Usually, the common factor is the first thing that you need to check for before you can go ahead and check for other types of factorization, like the ones we're going to look at in the next few examples. So let's have a look at an example of the type of questions we'll deal with involving factorizing by a common factor. So there we have 2 sine theta, tan theta minus tan theta. Let's go over to our writing pad and let us see how we can go about doing this. So, if my pen could come back to life, I would be very happy. We've got 2 sine theta, tan theta, minus tan theta. So now let's see which term or which trigonometric ratio is present in each of these terms. We've got tan theta, we've got tan theta. So our common factor in this instance is tan theta. What I do is I write down the common factor and then I introduce a set of brackets. What I need to do now is I need to take each term and divide it by the common factor. So I'm going to take the first term, which is 2 sine theta, tan theta, and I'm going to divide this by the common factor, which is tan theta. You're just going to remain with 2 sine of theta. So let's put the 2 sine of theta in the brackets. And then let's move on to the next term. So the next term we have is negative tan of theta divided by our common factor, which is tan theta. Your answer here is negative 1. So let's go ahead and put the negative 1 into the bracket. And there we have it. We are done factorizing this expression. Brilliant. Let's go over to the notes and see what the next question is. Okay. We've got sine cubed x plus sine x cos squared x. Let's go back to our writing pad and have a look at this one. So we've got sine cubed x. This looks terrible. Sine cubed x minus, sorry, this is plus sine of x and cos squared x. Now once again, what we need to check here is there a trig ratio that's present in both terms? Yes. We've got sine cubed x, we've got sine of x. So we've got sine of x in each of the terms. Let us actually write down sine of x as our common factor. Our next step would be to divide each term by the common factor. So sine cubed x, our first term, divided by our common factor. This is going to give us sine squared x. So I can go back and write down the sine squared x right there. Now I need to take the second term and divide it by the common factor. So sine of x cos squared x divided by my common factor, which is sine of x. This is just going to give you cos squared x. So let's go back and let's write down the cos squared x. There we are. You would remember from the square of the Pythagorean identity that sine squared x plus cos squared x, this is just going to give us a value of 1. Sine of x times 1, this is going to give us sine of x. Brilliant. We are done factorizing this expression. Alright, the next question says sine of x plus tan of x. Now let's have a look at this one. So let's just make some space here. We are looking for sine of x plus tan of x. Now, when you look at this at first glance, you will think to yourself, but there is no trig ratio which is present in both of the terms. But you will remember from the identities that I can write tan of x as sine of x divided by cos of x. Now, the first sine of x, the first term that we have here, you can think of this as a fraction over 1. Both my numerators are sine of x. So I can think of my common factor as being sine of x here. Now, sine of x divided by my common factor, which is sine x, will give me 1. Now let's look at what happens when we divide the second expression. So we've got sine of x divided by cos of x divided by my common factor. You would remember that this is going to give you sine of x divided by cos of x multiplied by 1 over sine of x. In such an instance, the sine of x and the sine of x will cancel out. You remain with 1 over cos of x. So let's go ahead and fill this in. This is going to be 1 over cos of x. Brilliant. We are done factorizing the expression. Alright, the last example here. We've got 1 over tan squared theta plus cos squared theta minus cos to the power 4 theta. This is a very interesting one. Let's take a look at it. So first, let me get some more room, some more space. This is 1 over tan squared theta plus cos squared theta minus cos to the power 4 theta. Alright, now we know from the quotient identity that tan squared theta is the same as saying sine squared theta divided by cos squared theta. Plus, let's leave the other two terms as they are, cos squared theta minus cos to the power 4 theta. Now, I do not like how the situation looks like on the first term when we have a fraction over a fraction. So because it's 1 over, I can just invert the numerator and the denominator, end up with cos squared theta divided by sine squared theta plus cos squared theta minus cos to the power 4 theta. Now when I get to this point, I can see that I've got cos squared theta, cos to the power 4 theta. So that should tell me that my common factor is going to be cos squared theta. Now, if you remember the division that we've done in the previous section, or in fact, let me just do it for the sake of clarity. If we take cos squared theta and divide it by sine squared theta, we divide this by our common factor, which is cos squared theta. We are going to end up with cos squared theta divided by sine squared theta multiplied by 1 over cos squared theta. The cos squared theta and the cos squared theta will cancel out. We will remain with 1 over sine squared theta. So the first term we're going to have in our bracket will be 1 over sine squared theta. Then cos squared theta divided by my common factor will just give me positive 1. Cos to the power of 4 theta divided by cos squared theta. This gives me minus cos squared theta. Let's just get some space here. Now you would remember from your identities that 1 minus cos squared theta is a special identity that's going to give us sine squared theta. So I could just go ahead and replace it. I could say this is cos squared theta into 1 over sine squared theta plus sine squared theta. And by so doing, I have answered the question. Brilliant. I hope this makes sense to you guys. I hope you guys are enjoying this. If you do enjoy it, if you do like it, please give us a like, subscribe to the channel, and share the video with other people so that everybody can benefit from the knowledge that we're sharing here. All right, let's move on to the second method of factorizing, which is the difference of two squares. Now, the difference of two squares consists of an expression that has two terms which are perfect squares separated by a negative sign. Another way you can think about this is you've got two terms, perfect squares with different signs. Now, in order to factorize a difference of two squares, you open two sets of brackets. For each set of brackets, you write down the square root of the first term. You put a plus sign in one bracket and a minus sign in another bracket. The last step would then be to write the square root of the last term in each of the brackets. I know this was a lot of words, this was a bit verbose. Let's look at a practical application of it. So here we are, we've got sine squared theta minus 10 squared theta. Let's go to our writing pad, writing board, and let's open up a new sheet of paper. There we are. So our expression is here. We've got sine squared theta minus tan squared theta. So the first question is, how many terms do we have here? We've got two terms. Yes. Are these two terms perfect squares? Yes. Do these two terms have different signs? Yes. Therefore, we can use the difference of two squares. Now, let me show you how to do this. We open a set of brackets. That was a terrible closing bracket. And then we open another set of brackets here. To get the first term in each bracket, we take the square root of sine squared theta, which is our first term. This is going to give us sine of theta. So I can include the sine of theta here, and I can include the sine of theta there. Next, I put a plus and a minus. Honestly, the order doesn't matter. You can put minus first and plus after, or plus first and minus after. The answer would still be the same. Now we say, what is the square root of tan squared theta? This just gives us tan of theta. So I can put tan of theta here, and I can put tan of theta in my second bracket. Lovely. Life is great. We are done. Let's look at the next section. Right, we've got tan squared alpha minus cos squared alpha. Let's have a look at this one. So pretty much the same procedure. If my pen will allow me to write, I would be so thankful, so happy. Okay, there we are. We've got tan squared alpha minus cos squared alpha. Right, so once again, is this a difference of two squares? Well, first of all, do we have two terms? Yes, we do. Are these two terms perfect squares? Yes, they are. Do they have different signs? Yes, they do. So this is a difference of two squares. So we open two set of brackets again. Now, to get the first term, we need to find the square root of tan squared alpha, which is just going to give us tan of alpha. So this is tan of alpha, and we've got tan of alpha here. Then we proceed by putting in the signs. Next, we say, what is the square root of cos squared alpha? This is just cos of alpha. So we include cos alpha here, and we include cos alpha there. Brilliant. We have answered the question. We have factorized it successfully. Wonderful. Now for the next question. This one is a bit interesting. Negative cos to the power 4x plus sine to the power 4x. Let's see what we could do here. So if I could just make some room, we have got negative cos to the power 4x plus sine to the power 4x. Now, we've got two terms. They've got different signs. Are these perfect squares? At first glance, you might be thinking, but in the previous two questions, we had exponents of 2. We don't have an exponent of 2, therefore this is not a perfect square. No. For a term to be a perfect square, and this is where a lot of people don't get it, a perfect square is not just a term with an exponent of 2. A perfect square is any term with an even number as an exponent. So for all we know, we could have x to the power 12. That is still a perfect square. For as long as the exponent is divisible by 2, that expression is a perfect square. That term is a perfect square. All right. Now, I don't really like the way this is written. What I'm going to do is I'm going to rewrite it to have the positive term first and then the negative term secondly. Now, this is a difference of 2 squares. Let's open our set of brackets like that. To get the first term, I'm going to say square root of sine to the power 4x. That's going to give me sine squared x plus, oops, let me put a sine squared x in here as well, minus. Now, the square root of cos to the power 4x, that's just going to give me cos squared x and cos squared x. Once again, from our square identity, this is going to be 1, and this is just going to remain as sine squared x minus cos squared x. Let's take a look at something here. You might be thinking, okay, right, we're done. But when you look at this, you will realize that this is actually still a difference of 2 squares. So we can further factorize that part. So I can open 2 sets of brackets again. At this time, I'm going to have sine of x minus cos of x. And I'm going to have sine of x plus cos of x. There we have it. This is the final step. We have factorized the expression. I hope that this makes sense to you guys. If anything I'm saying does not make sense, or you feel like I'm moving too fast, please do let me know in the comment section, and I will slow down in the next video or re-upload the video if need be. Alright, now we get to the trinomial. Now with the trinomial, we know it's a trinomial because it has 3 terms. Remember, the prefix tri means 3. 2 of these terms will have the same trigonometric ratio. One would most likely be a number. The last one would be a number. If it so happens that these expressions, these 2 terms are not the same trigonometric ratio, you could use the square identity to make them the same. I'll show you in detail what this means in a second. The 2 trigonometric ratios have different exponents. The last term is a constant, as I've mentioned, it's a number. And sometimes it's easy to visualize a trinomial by substituting the trigonometric ratios with variables. I'll show you what I mean in the examples that follow. So to factorize a trinomial, make sure that the expression is in the form ax squared plus bx plus c. I hope that this is bringing something back to your mind. I hope it's recovering your memory. You've seen this before somewhere. I know you have. You write 2 sets of brackets. We need to find factors of the first term and write them as the first terms of each set of brackets. You need to then consider the second and last term. If the last term is positive but the middle term is negative, you put a minus in each set of brackets. In other words, what we're saying is, if the last term is positive, your signs will be the same. If the middle and last terms are positive, the plus sign is in each bracket. If it happens that the last term is negative, you put a plus in one bracket and a minus in the next bracket. We then need to find factors of the last term, such that when we add them, we get the coefficient of the middle term. I know just reading this on its own, as a lot of work. So let's look at it in a practical sense. So here we have an expression, cos squared x minus 7 cos x plus 10. Let's look at this one. So once again, let's open a new sheet of paper and let's copy down the question. So we have got cos squared x minus 7 cos x plus 10. Now, one thing I like to do is notice something. There's cos here, there's cos here. How about we use a different variable to represent cos of x? I can say something like let k equals to cos of x. Now my expression will look more like an algebraic expression than a trigonometric expression. This is easier to simplify. So as we said, we need to have two sets of brackets. The square root of the first term, the square root of k squared is k. So we put a k there, we put a k there. Let's take note of something. The last term is positive. So positive means that we're going to have the same signs inside of the brackets. How do we know which sign it's going to be? Well, you look at the middle term. Since the middle term is negative, both of my terms will be negative. Remember, we said same signs. All right, now we need to find factors of 10. I'm going to list them on the side. We've got 1 and 10. We've got 2 and 5. We've got 5 and 2. We've got 10 and 1. Now, notice that I did not look at the negative factors because in any case, my signs are the same. If it happened that we had different signs, then the signs of the factors would also be important. Now, I'm going to have to add each of these terms and see which one gives me the middle term in our expression. So, 1 plus 10 is 11, 2 plus 5 is 7, 5 plus 2 is 7, 10 plus 1 is 11. Now, notice we've got 2 7s and 2 11s, but this is important, especially if it happens that the signs inside the bracket are not the same. I'm going to use this. 2 plus 5 gives me 7. 7 is the coefficient of the middle term. So I'm going to put minus 5 and minus 2 there. Now, initially, our expression did not have k's. So we can go and substitute the cos x back in. So this is going to be cos x minus 5. And this is going to be cos x minus 2. There we are. We are done factorizing this trinomial. All right, the next one says sine squared x plus 3 sine x minus 21. Let's have a look at it. So let's get some more room. We've got sine squared x plus 3 sine x minus 21. Right, once again, since I've got sine squared, sine x and sine x here, how about I let sine x equals to something like m this time around? Technically, you can use any variable as long as it's not the same as the angle that we have in our trig ratio. So I'm going to have here m squared plus 3m minus 21. So once again, I have to open two sets of brackets. The square root of m squared is m, and this is m. Notice that my last term is negative. A negative last term means we've got different signs inside of our brackets. So I could just straight away go ahead and put plus here and put minus. Now I need to find factors of negative 21. I'm going to write them on the side. I've got negative 1 and 21. Let's see. I've got negative 3. 2 does not go into 21. Yes. I've got negative 3 and positive 7. Let's see what else I have. 4 does not go. 6 does not go. I've got negative 7 and positive 3. I then have, let's see, negative 21 and 1. Now, when I add these, you will see that negative 1 plus 21 gives me 20. Negative 3 plus 7, it's going to give me 4. Negative 7 plus 3 is negative 4. Negative 21 plus 1 is negative 20. None of these actually give me the coefficient of the middle term. So in such a scenario where factorization is not possible, you could still go ahead and use the quadratic equation that you remember from algebra. Now, because we're not really solving for anything here, I'm not going to use the quadratic equation, but just in case it was a setup in which you had equals to 0 here and you had to, do your general solution, that's when you would use the quadratic equation to get the sine of x is equals to some number and sine of x is equals to another number, which you can then use to go ahead and do your general solution, get your reference angle, etc. I will upload a video on general solution shortly, but yeah, this is typically the type of approach you would have taken had this been a general solution question. All right, and then we have the last question here. Let me just take this question down. So yeah, I think I can work with this space. No need for a new sheet of paper. So we've got sine squared x plus 12 sine of x plus 45. So what I can do here is I will notice that my term with the highest exponent does not have a positive sign. It actually has a negative sign. So what I can do here is let me take out a common factor of negative 1. Remember what I said to you at the beginning when we started with common factor. You can only, in fact, you must always check for a common factor first before you follow any other forms of factorization. Otherwise, you're going to end up on the wrong end. So we will have here sine squared x minus 12 sine x minus 45. Now what we can do is we can factorize within the brackets. The square root of sine squared x is sine x. This is sine x. Notice something. Our last term is negative. Because of the negative, we've got different signs inside of our brackets. Please take note, we are no longer using the expression which has positive 45 because we took out a negative 1 as a common factor. So let me put minus and plus here. Let's look at factors of 45. I've got negative 1 and 45. I've got a negative 3 and 15. Let's see. What else do I have? Negative 5 and 9. Okay, 10 does not go in there. 12 doesn't. Okay, we've got negative 15 and positive 3. We have negative 9 and positive 5. Then we have negative 45 and positive 1. Once again, I need to add these. So, negative 1 plus 45, this gives me 44. Negative 3 plus 15, this is going to give me positive 12. Negative 5 plus 9, this is going to give me positive 4. Negative 15 plus 3, this is going to give me negative 12. Aha! The coefficient of our middle term is negative 12. So I'm going to take negative 15 and positive 3 as my values. Please take note that in this instance, I did not use the approach of algebra, but you could as well just do the same thing. So you could say negative sine squared x plus 12 sine of x plus 45. Then you could say something like let p equals to sine of x. You will have negative p squared plus 12p plus 45, which again you can take out a negative 1 as a common factor. So this is p squared minus 12p minus 45. And you will end up here with two sets of brackets where you've got p, let me put a plus, let me put a minus. Since we've identified the factors already, we've got minus 15, we've got positive 3. When you do it this way, always remember to go back to what you started with here and substitute the correct trig ratio back into the equation. So we're going to have sine of x plus 3, and we're going to have sine of x minus 15. And that's exactly the same as what we have in the first approach that I've used. I hope this makes sense to you guys. Once again, if you do enjoy the video, please give us a thumbs up and please share the video. Subscribe to the channel as well. Alright, now we look at the sum or difference of two cubes. Now, similar to the difference of two squares, we've got a difference of two cubes. We also have a sum of two cubes. Notice, just because we have a sum of two cubes, it doesn't mean we've got a difference. Sorry, it doesn't mean we've got a sum of two squares. It's okay to have a sum of two cubes, but we don't have a sum of squares. So the sum or difference of two cubes can be identified by two perfect cubes. So what is a perfect cube? This is a number whose cube root is a rational number. We can also say it is an expression or it is a term whose exponent is divisible by 3. Remember what we said earlier about the difference of two squares, that the exponent is divisible by 2. For difference of two cubes, the exponent is divisible by 3. It doesn't necessarily have to be a 3, but it must be divisible by 3. Alright, let's say we've got an expression where we've got x cubed minus y cubed. So this is a difference of two cubes. The order of signs that you're going to use to factorize this is you've got a negative plus plus. If this doesn't make sense, we'll see it in detail in the examples. If you have a sum of two cubes, you've got plus minus plus. To factorize a sum or difference of two cubes, you've got two sets of brackets, a small bracket and a big bracket. In the small bracket, the cube root of the first term gives you the first term in the bracket. The cube root of the last term gives you the second term in the first bracket. To get the first term in the big bracket, you square the first term in the smaller bracket. To get the second term of the big bracket, you multiply the two terms in the small bracket. To get the last term in the big bracket, square the last term in the small bracket. Once again, this is a lot of reading. Let's do it practically. There we are. We've got sine cubed theta plus cos cubed theta. So let's open a new sheet of paper and let's write this out. You've got sine cubed theta plus cos cubed theta. So this is a sum of two cubes. You start off with a small bracket, then you have a big bracket. If you have a plus here, your signs are going to be plus, minus, plus, always. Right. To get the first term, I need to find the cube root of sine cubed theta. We are finding the cube root here. This is going to give you sine of theta. So the first term in the small bracket is sine of theta. To get the next term in the small bracket, we need to find the cube root of cos cubed theta. This is just going to give me cos of theta. So let me write here cos of theta. Now to get the first term in the second bracket, I have to square the first term in the first bracket. So I have to say sine of theta squared. This is going to give me sine squared theta. I've got sine squared theta here. Let me just make the brackets a bit wider so that we can have ample space to work with. This is a bit crowded. Let's get the pen back. All right, there we are. Remember we had a minus here. So to get the second term, I need to multiply these two guys. Sine theta times cos theta will give me sine theta, cos theta. To get the last term, I have to square the last term in the first bracket. So cos of theta squared is equals to cos squared theta. I have cos squared theta here. If you want to, by using your identities, to be specific, your square identity, sine squared theta plus cos squared theta, this gives you 1. So I'm going to write this as 1 minus sine of theta, cos of theta. And this is my final answer. All right, let's look at the second one. We've got 1 minus 10 cubed alpha. So let's write that, some space. We've got 1 minus 10 cubed alpha. So now we once again have a small bracket and a big bracket. If your sign is negative, you will have a minus, plus, plus, always. So let me just erase this because now it looks like an equal sign. Right. So now, to get the first term in the first bracket, I have to cube root the 1 and I get 1. To get the second term, cube root the 10 cubed, I get 10 of alpha. To get the first term in the second bracket, I have to square the 1. 1 squared is 1. To get the next term, I have to multiply the 2. 1 times 10 of alpha is just 10 of alpha. To get the last term, I need to square the last term. I need to square this 10 of alpha. This would give me 10 squared alpha. So there we are. This is 10 squared alpha. There we have it. We are done factorizing it. I hope it makes sense. If there's something that you don't understand, please just put in the comment section and I shall be happy to assist. Alright, lastly, we've got cos cubed theta minus 1 over 64. That's still a difference of 2 cubes. So let's look at it. We've got cos cubed theta minus 1 over 64. So we said we have 2 sets of brackets, and once again, because this is negative, I will have minus, plus, plus, always. Now, the cube root of cos cubed theta is cos theta. The cube root of 1 over 64 will give you 1 over, let's see, 4. To get the first term, I have to square cos theta. Cos theta squared gives me cos squared theta. To get the next term, I have to multiply these two. If I multiply these two, I get 1 over 4 cos theta. So 1 over 4 cos theta. To get the last term, I have to square the 1 over 4. 1 over 4 squared gives me 1 over 16. There I am, done. Life is great. I hope this makes sense to you guys. Alright, we are on our last type of factorization, which is the grouping. So we use grouping when we have an expression that has 4 or more terms. So to factorize using grouping, what you need to do is I need to identify the pairs of terms with a common factor. So there's going to be groups of 2 terms which have a common factor. Take out the common factor for each group. Simplify the resulting expression. So let's look at the first example. There we are. Let me go back to the writing pad and let's actually open a new sheet of paper. Okay, so let's see what we have here. We've got 6 tan of, let me just go back here. So that's 6 tan of x. So 6 tan of x plus cos of x plus 2 tan x cos x plus 3. All right, so let's see. How do we actually simplify such an expression? We need to find the terms that have a common factor. Here's what I can do. I can take 6 tan x and the 3. And I'm going to write these next to each other. So 6 tan x plus 3. Next, I am going to take cos of x and 2 tan x cos of x and write them next to each other. So plus cos of x plus 2 tan x cos of x. Let me see if I could use a better color because this is a bit sharp on the eyes. So let me just erase this part. Okay, we have got cos of x plus 2 tan of x cos of x. Now what I'm going to do is I need to identify a common factor here and I need to identify a common factor there. My common factor in the first bracket is going to be 3. I remain with tan of x plus 2. In the second bracket, my common factor is cos of x. I remain with 1 plus, let's see, 2 tan of x. There we have it. We're done. We can't simplify this any further. Usually what would happen is you would have the brackets have the same expression and then you would factorize that as a common factor. But in this instance, we do not have such a setup, so this would be our final step. All right, let's look at the next question. This is an interesting one. So sine squared alpha minus 2 sine alpha minus sine alpha cos alpha plus 2 cos alpha. Okay, that was very rhythmic. So let's go onto our writing pad and let's copy down the question. So we've got sine squared alpha minus 2 sine of alpha. Let me just check if I'm copying the correct thing. Yes. All right. Minus sine of alpha cos of alpha plus 2 cos of alpha. Once again, we need to choose, and be very careful on how you make your choice here. We need to choose which terms have a common factor within them. So what I'm going to do once again is, let me choose a proper color. Let's use red. I am going to group sine squared alpha and minus 2 sine alpha. Then I'm going to group minus sine alpha cos alpha and 2 cos alpha. So these are already next to each other, but let me just rewrite this. I'm going to put brackets around them because I want to group them. I want to isolate them. So this is 2 sine of alpha. I'm going to put the negative sign outside. Then I'm going to remain with, or maybe what I should do is let me put a plus here, but let me rewrite the order of the terms. So this is going to be 2 cos alpha minus sine alpha cos alpha. I'm just trying to remain consistent here. In the first bracket, my common factor is sine of alpha. I will remain with sine of alpha minus 2. The second bracket, my common factor is going to be cos of alpha. Oops. And I will remain here with 2 minus sine of alpha. Now there's something interesting happening here. I've got 2 minus sine of alpha in the second bracket and sine alpha minus 2 in the second bracket. Sorry, in the first bracket. What I could do is I can make them have exactly the same terms with exactly the same signs. So what I'm going to do is let me leave the first term as it is. So this is sine of alpha minus 2. But for the second one, I'm going to take a negative sign outside of the bracket so that way this becomes sine of alpha minus 2. I've got sine of alpha minus 2, sine of alpha minus 2. I can treat this as a common factor by placing it on its own, sine of alpha minus 2. Then I only remain with these two terms which were left over. So I remain with sine of alpha minus cos of alpha. By so doing, I have simplified the expression. I hope that you guys enjoyed this lesson. I hope that you enjoyed this video. You found it productive. You find it useful. Thank you so much for watching. And if you do find the video useful, please do subscribe to our channel. Like the video and share it with people. And let's keep sharing. Let's keep distributing. Let's keep distributing the knowledge. Thank you guys so much for joining us, and enjoy the rest of your day until we see each other in the next video. Ciao.